Welcome to the video tutorials for SILCS-Bio. In this video, we will go over how to build pharmacophore models with SILCS-Pharm calculations using the graphical user interface. For this tutorial, you will need the directory with SILCS frag maps for your target. You should have generated these using the SILCS simulations module. Additionally, you will need the location of binding pocket defined by either an existing ligand file or protein residues around the binding site or the XYZ coordinates for the center of the pocket. The information discussed in this video is also available on our documentation website docs.silcsbio.com. You can go to Silk Small Molecule Suite, then go to SILCS-Pharm, then go to Running SILCS-Pharm, and then go to SILCS-Pharm using the SILCS-Bio GUI. Let's start a new SILCS-Pharm project. Hope you have generated the SILCS frag maps for your target. If not, you will have to get those using the SILCS simulations module before moving forward. Now we'll go to the SILCS-Pharm section on the right bottom and click on New SILCS-Pharm project. Next, we come to the setup page. Here we need to provide some inputs or choose some settings. First, we need to give a project name. Next, we provide the SILCS frag maps directory location. Navigate to your directory and just click on the directory icon without entering the directory and click open. This will automatically select the protein PDB file for you. There are no additional settings in this case and we can click the setup button. Next step is defining binding pocket. On the next page, we can see a summary screen with the project name, protein PDB file, and pharmacophore search options. First, we need to define the search region by selecting the pocket center and radius. Click the Select Pocket button on the right hand side of the window. Now the protein and frag maps are loaded to the center stage. On the right hand side, in the Pocket tab, we will need to define the pocket center. By default, the option is Define Pocket using ligand, which will use the center of geometry of a ligand pose. Second option is Define Pocket using selection, which allows us to provide a target's residue selection, and the center will be calculated as center of geometry of selected atoms. Lastly, Define Pocket by XYZ option can be used to directly enter the XYZ coordinates. This can be based on SILCS hotspots output. Here, let's select the crystal ligand to define pocket by clicking the Select File button. A red sphere will appear on the central panel to show the search region. Now it's time to adjust the radius. Allowed range is 1 to 15 angstroms. Let's keep the radius to default at 10 angstroms. Click the Save Pocket button and then click the OK Acknowledgement button to continue. Let's move on to running the SILCS-Pharm calculation. We have returned to the previous screen, which now shows sampling region information consisting of the spherical pocket center and radius. We also see default frag map cutoff values listed for selection of frag map densities to be used for creation of the pharmacophore features. You may adjust these values if you desire, though we recommend keeping them at these default values. Click on the Run SILCS-Pharm button to run the 4-step SILCS-Pharm process. A command execution window will appear and show job output as the job will run to completion in a matter of seconds. Click the green Search Finished button. Now let's visualize the pharmacophore features. Next, on the results page, the pharmacophore features are loaded to the stage along with the protein and frag maps. By default, our camera will encompass the whole protein structure. So to focus in on our pharmacophore features, we can go to the sidebar menu and click on the zoom button. Okay, here is a better look at our features that we are working with. Now we deselect and select features by clicking on the check boxes next to them, or we can easily deselect or reselect all of these by clicking on the checkbox next to the feature name. Okay, here we will select 4 of these features. Now, if we want to compare these features to the frag maps, we can go to the frag map tab in the sidebar and customize their visibility. So I'm going to turn on the positively charged maps, and we can see the positively charged maps are quite favorable here and occupy a large space. So let's say I want to adjust the radius of my cation feature to be larger. We can adjust the size by toggling on the plus or minus buttons. Now let's check distances between the pharmacophore features. So to calculate distances between your features, you can simply use these drop-down menus to select two features for which you want to calculate the distance between. So we can see here that these two features are about 7.75 angstroms apart. And if you want to clear the measurement, you can click on the clear button. Let's see how we can save our pharmacophore hypothesis now. Now we can save our pharmacophore models that we built in a PH4 file format that is compatible with either Farmer or Mo. Let's save our selected set of features for Farmer by clicking the Save Feature Farmer button. Note that Farmer can handle limited definitions of the feature types as compared to Mo. You can refer to running a pharmacophore screening with this hypothesis on command line interface using Farmer on our documentation site. Let's see how the project files look like. To access the project files, we can start on the home screen and go to Continue SILCS-Pharm project. Go to our project and click on the Show Project Directory on the right. This will open the default file browser for the directory of our project. Here we can see the SILCS-Pharm files along with our recently saved .ph4 file. Alright, thanks for watching the tutorial. See you next time.